Okay, what I'm going to show you with interval notation for inequalities in a single variable, when we do inequalities with multiple variables on the coordinate plane, we'll be doing this in exactly the same way with exactly the same ideas. Okay? First, we need to go from the inequality to the graph. So if I've got x is greater than 3, then on a number line, the point I'm going to care about will be 3. What I like to see is a point on either side of that. So one point to the left of 3 would be 2. To the right would be 4. 2, 3, 4. If you had a fraction, again, going to the integers tends to work a little bit better in terms of showing exactly where that point is on the number line. So if x is greater than 3, this is called a strict inequality. X is strictly greater than 3. It cannot equal 3. So at 3, I'm going to use an open circle because I can't equal 3. I can get right up to 3, but I can't actually equal it. Then you can use those points on either side to determine whether this is a true or a false statement. If I use 2, is 2 greater than 3? Nope, that's false. If I use 4, is 4 greater than 3? That's a true statement, open to the larger number, alligator eats the bigger number. So I'm going to shade the side that's true. And rather than just doing a really dark line, because what happens typically if you're using pencil and paper is you'll end up simply tearing through your paper, I just actually shade that. Be sure you go right up to that open circle. Okay. So here is my graph. This is my inequality. And then as an interval, I read from the graph. Read from left to right. When I am reading from left to right, the first place my pen would go down is at 3. Is 3 included? Nope, open circle, so I use parentheses. I use parentheses anytime a number is not included. Then a comma, and then when do I lift up my pencil? I never do that. Shading goes on forever. So I go to infinity. And infinity is like a Mobius strip. And the last number in infinity, well, there isn't one. Think of the largest number you can. I can add 1 to it and get a larger number. So I can't include a last number. Always parentheses around infinity. So here's the interval. If I have x less than or equal to 25, well, on my number line, point I care about is 25. 25 is in between 24 and 26. Now, open or closed circle at 25. Well, we have equality, so it could equal 25, so we'll use a closed circle. Now I decide which way to shade. 24 less than or equal to 25? That's true. 26 less than or equal to 25? That's false. So, shade to the left. Reading from left to right. Well, my pen goes down as far to the left as I can, so that's going to be negative infinity. What's the last number? Well, again, infinity doesn't have a last number, so we can't include it. Always parentheses around infinity. Comma, and I go all the way up to 25. That's where I lift my pen. 25 is included, closed circle. X could equal 25. So bracket around that. So if you have open circles, you're doing parentheses, closed circles, brackets. Do be careful. I see some students try on a test, well, I mean a bracket, no, I mean a parentheses. And it's not clear what they had meant, whether it was a bracket initially or a parentheses. And sometimes you see people do half attempts. Be sure it's really clear, parentheses or brackets, and otherwise simply rewrite it. We can have a compound inequality. Negative 7 is less than x is less than or equal to negative 2. Well, here on my number line, I need negative 7 and negative 2. Be sure you have these points in the correct order on the number line. Don't have negative 2 here and negative 7 here. At negative 7, not included, so open circle. At negative 2, included, so closed circle. X is more than negative 7 and less than negative 2, so it's trapped in between those. Reading from left to right, my pen goes down at negative 7, open circle, so parentheses, the number is not included. My pen stays down until negative 2, closed circle, bracket, and then my pen isn't down again. That's the interval notation. So these two are compound inequalities. Sometimes this will be called a double inequality or a three-part inequality because you have the three parts together. And this would be using an and. With an or, I'm going to graph these both on the same number line. X is less than or equal to negative 6, or x is greater than or equal to 6. So I need negative 6 and 6. Again, put these in the right places for the numbers on the number line. Less than or equal to, well, equal to, so at negative 6 I'll have a closed circle. I want all the numbers that are smaller than negative 6. I can use the 6 as a test. 6 less than or equal to negative 6 is false, so I can't shade the side that includes the 6. I shade the other way. X greater than or equal to 6, well, we've got the equality, so x could equal 6, so closed circle. And I'm shading here the numbers that are more than 6. Negative 6 makes that a false statement. Shade the other way. Going to the interval notation, reading from left to right. My pen goes down at negative infinity. Infinity, always parentheses. I shade up until negative 6. Negative 6 is included, so bracket. Then I lift my pen. Then I put it down again. The way I'm going to indicate that joining is with a U for the union. So this U stands for the union, and it's the mathematical or. Upside down U is the intersection, and that's the mathematical and. And I start here at 6, included, closed circle, bracket, and shading continues forever, continues forever, infinity, infinity always parentheses. And you can have multiple intervals chained together. Now, one last example where I see a number of students make mistakes. Let's say I had negative 4 less than or equal to x, because my variable can be on either side of the inequality, and you don't want to just look at the inequality sign to determine which way to shade. You want to be sure you're shading the side that is true. So in this case, well, negative 4 is what I care about. I'm going to have a closed circle there because x could equal negative 4. Now, negative 4 is between negative 5 and negative 3. Now, if I'm checking negative 5, my statement would be negative 4 is less than or equal to negative 5. That is a false statement. I would I'd rather owe $4 than owe $5. Negative 4 is more than negative 5. Negative 4 is less than or equal to x. If I plug in negative 3 for x, that gives me a true statement. I'd rather owe $3 than owe $4. Owing 3 is the larger. So shade the side that's true. Interval, left to right, negative 4, included, so bracket, continue on forever, infinity, parentheses. Okay. So here I've got a less than sign but I've shaded to the right. Again, you're shading the side that is true.